Data obfuscation is a series of techniques designed to hide or mask data or a portion of the data. This is often used when an organization doesn't fully trust the people who manipulate the data, or they don't want to expose those people to the data because of certain regulations. This helps protect the confidentiality of data as it's being manipulated. So for a health insurance company might only allow their representatives, customer service representatives, to view like the last four of a patient's social security number, or a certain key piece of information that they can use to identify the individual on the phone, but not all of the information associated with that user's account. Data masking is when you hide characters with basically useless characters. So if we're hiding everything but the last four of a social security number, we might use asterisks like this. Oftentimes you'll find this as a requirement, at least with HIPAA, Health Insurance Portability and Accountability Act. Nulls, instead of masking, will display nothing instead of the actual data set. Randomization replaces the data with random characters. And shuffling uses different entities within the same data set. It's not really ideal to use shuffling because you're actually using real data, and you could technically come across the entire social security number if you use shuffling and it happened to randomize in a certain way. So not nulls, randomization, and masking are usually much better. Exclusive XOR is a data obfuscation technique. It's a logical operation that's used in many different types of ciphers, like block and stream ciphers. XOR is a technique where two bits of information are calculated and applied. So it's easiest to explain if I just go through an example. So if we have two bits of information, we have a first bit, first string, a second bit, okay? If the two bits are the same, you're going to come out with a 0. So if we have a 1 and a 1, that's a 0. If it's the same, it's a 0. So 0 and a 0, that's a 0. If they're different, it's a 1. 1, 0 would be 1, 1, 0 would be 1, 0, 1 would be 1. And then we just go down the list. That's all it is. That's all there is to it. But it's a technique. By understanding this, you can understand how different block ciphers work. We'll talk about those later in the course. Tokenization is the process of replacing actual values in a database with representations of that data known as tokens. Those tokens do not represent the actual values of the data. Instead, they are random digits created to replace the digits within the database. Tokenization does not use any algorithm or mathematical function. Instead, tokenization refers to a token vault, which is a separate database that is used to associate with each value. So we have a social security number and it's entered. This is the plain text, the actual value social security number. Tokenization, or the token vault, would associate a random string of characters, which would be represented here, and then display that instead of the actual social security number. This is a form of obfuscation in which people accessing the database would only see these tokens or these representations, and only through the token vault can the actual value be derived. It's a form of obfuscation because the token vault does not apply any form of encryption, and oftentimes the token vault needs to be encrypted itself. So instead of showing the actual value, tokenization shows a token or representation of it.